Today I'm at your service with another haul. Hi, it's Drake and welcome to our Drake channel, a channel for all things. Today I'm going to talk about another hole. White holes. You probably heard loads about black holes, but what on earth are white holes? Do they actually exist? And how are they linked to their dark cousin, black holes? In this video, we've been embarking on a cosmic journey to unravel these enigmatic objects. So stick with me, and if you enjoy it, don't forget to give us a thumbs up and hit that subscribe button. What are white holes? Let's start with the basics. In simple terms, a white hole is a hypothetical cosmic object that behaves like the complete opposite of a black hole. While black holes gobble up everything, even light, and let nothing escape, white holes are like cosmic fountains. They spew out matter, light, and energy, and nothing can get inside them. Picture a black hole as a massive cosmic vacuum cleaner, sucking in everything in its path. A white hole, on the other hand, is like a cosmic firework, blazing matter and light outwards with tremendous force. This makes white holes sound utterly bizarre, as we don't often see anything like this in the real universe. Where did the idea of white holes come from? The concept of white holes springs from Einstein's general theory of relativity. When scientists were solving Einstein's equation for black holes, they stumbled upon another solution, something that works the opposite way. This mathematical curiosity was explored further in the 1960s by mathematician Martin Kruskal and others, leading the idea of white holes. Here's the catch though. White holes only exist in the mathematics so far. We haven't found any physical process in the universe that could naturally create a white hole. Black holes form from the collapse of massive star and supernova explosions, but white holes, there's no known mechanism for them to pop into existence. An intriguing idea is that white holes might be time reverse version of black holes. Imagine running a film of black hole backwards. It might look like a white hole, chucking out matter and light instead of swallowing it. How do white holes differ from black holes? Absorption versus emission. Black holes pull everything in, including light, while white holes fling matter and light outwards. Event horizon. Both have an event horizon, but they work differently. In a black hole, the event horizon is a boundary nothing can escape from. In a white hole, it's a barrier nothing can cross to get inside, as everything is being pushed out. Physical properties. Both have mass, electric charge, and angular momentum, but their behavior is polar opposite. Existence. Black holes have been confirmed with observation, but white holes remain purely theoretical. No one spotted one yet. If you try to fly a spaceship towards a white hole, you'd never get close. The flood of energy and matter pouring out which keep pushing you back, like trying to swim against a cosmic tsunami. White holes and their role in the universe. So what part might white holes play in the universe? There are a few fascinating theories. The Big Bang connection. Some scientists speculate that the Big Bang, the massive explosion that kicked off our universe, might have been a sort of white hole, spewing out vast amounts of matter and energy. It's a wild idea, but we've got no solid evidence for it. Wormholes. In a wormhole theories, black holes could act as the entrance to a space-time tunnel, with the white holes as the exit, possibly in another part of the universe or even a different universe altogether. I've already made a video about wormholes. It's above or maybe above. So, black holes to white hole transition. Some physicists like Hal Hoggard and Carlo Rovelli propose that when a black hole dies after shrinking due to Hawking radiation, it might transform into a white hole, releasing everything it once swallowed. This process, though, would take billions of years. Evidence for white holes. We've got no direct observational evidence for white holes. Unlike black holes, which we've confirmed through their gravitational effects on stars, gas clouds, and even direct images like the Event Horizon Telescope snapshot of the M87 black hole. White holes haven't been seen in a while. Some scientists have wondered if mysterious phenomena like gamma-ray bursts or fast-moving pulsars could link to white holes, but these are just guesses with no concrete backing. Another issue is thermodynamics. The second law of thermodynamics says that disorder entropy always increases. Black holes fit this by gobbling up matter. But white holes, by spitting stuff out, seem to defy this law, making their existence in the real world seem rather unlikely. Why white holes matter? Even if white holes are just a theoretical concept, studying them is incredibly valuable. They help us better understand general relativity and quantum mechanics, especially in extreme conditions like singularities. They might offer clues to solving the black hole information paradox, which questions what happens to information swallowed by a black hole. White holes could be a way for that information to re-emerge. They fuel existing ideas like wormholes and interstellar travel, which capture the imagination. Now, I think we've learned something good today.
Like what?
White holes are one of the most mind-boggling and thrilling concepts in theoretical physics. They're like a mirror image of black holes. Instead of swallowing this poo, yet for all their allure, we've no proof they exist in our universe. Thanks for joining me on this cosmic adventure. If you enjoyed this video, please give it a like, drop your thoughts in the comments, and subscribe for more sciencey goodness. If you got questions about white holes or ideas for future video, let me know below. Until next time, keep pondering the universe and wait for us until next week.